Namaste to all of you. Uh, what about my audio? Is this fine or do I need to change my settings? Hello. What about my audio? There is some response from chat. It's fine. Okay, thank you. So, Rishabh, thank you for your response and straightforward, not wasting either your time or my time. I'm straightforward coming to the topic, and topic today I'm going to discuss is binomial trees and binomial heaps. Right. So first let me give you formal definition of binomial heaps and binomial trees. Then I will move to the conceptual points. So first point is binomial heap is a collection of binomial trees. Right. So as I read out this definition, binomial heap is a collection of binomial trees. So you would definitely love to ask what is binomial trees. So binomial tree BK is an ordered tree that is defined recursively. That is, it is started from B0. B0 consists of a single node, and the binomial tree BK consists of two binomial trees BK minus 1 that are linked together, and the root of one is the leftmost child of the root of the other. So, the binomial trees are shown in this figure. Let me show taken by example. So B0 is single node, another B0 is single node. Right. So this is B0, single node, another B0 is again a single node. Right. So let me take the help of the definition. This is B0, B0. Now I would like to form a B1. In order to form a B1, what I need that B1 consists of two B0s that are linked together, and the concept of linking together is the root of one leftmost child is the root of the other. Right. So root of one is the leftmost child of the other. Root of one is leftmost child of the other. So this is B1 is taken. Now this is one B1. This is another B1. Right. Now I need to create B2. So this is B1, this is B1. So root of one is the leftmost child of the other. Right. Then I'm able to form a B2. Right. Suppose I want to form a B3. This is one B2. This is another B2. Let's take another color for your better understanding. This is B2. This is B2. Another B2. This is B2. Right. So this is B1. This is B1. I want to create, sorry, this is B2, this is also B2. I want to create B3. In order to create B3, I will need two B2s, one B2, one B2, and the root of one is going to be the leftmost child of the other. Done. So I'm able to create B3. In this way, I'm able to show how B3 and B4s are created. Right. Now, suppose there are, this is one tree bk minus 1, and this is another bk minus 1. I want to create bk. In order to create bk, what I will do, I will make root of 1 is the leftmost child of other. Right. So in this way, I'm able to create bk. Right. There is one more property associated with B trees, that this is depth 0, and depth 0 contains these number of nodes. Depth 1, these number of nodes. Depth 2, these number of nodes. Depth 3, these number of nodes. Depth 4, these number of nodes. So let me see how these are obtained. This is B4. So value of K is 4. Right. So let me calculate at depth 0, 4C0. What is the value of 4C0? Factorial 4 upon factorial 4 minus 0 upon 0. So it comes out to be all vanished, null and void. It comes out to be 1. So number of nodes at any depth I is KCI. Right. Number of nodes at any depth I is KCI. Let me clear all drawings. Okay. Suppose there is one more situation with binomial trees. This is a tree BK, and BK, this is B0, this is B1, this is B2, this is BK minus 2, this is BK minus 1. So BK is collection of all these B0, B1, and up to maximum BK minus 1. Right. So let me explain you the properties of PT. There are 2 raised to power k nodes. Okay, let me take an example. Example is like this. Just wait a minute. I will remove the phone so that no disturbance is there. Okay. This is, I will take another red color. This is B1, B1, yes. B1, B1. This is B2. Right. So the value of k is 2. So first property, there are 2 raised to power k nodes. 2 raised to power 2, that is 4. There should be 4 nodes in B2. 1, 2, 3, 4. There should be 4 nodes in B2. The height of tree is k. 1, 2. The height of this tree is 2. From root to leaf, longest sequence of edges. So height of tree is 2. There are exactly KCI nodes at depth 0, 1, 2, dot, dot, dot. That's property I have already explained. Now, for a root that has a degree k which is greater than any other root, moreover, if I is the children of the root are numbered from left to right, are k minus 1, k minus 2, dot, dot, 0 that I have already explained in the examples. Right. So let me move further. So now, we have got an idea of binomial trees. Now I'm going to understand the concept of binomial heaps. So in binomial heap, a set of binomial trees that satisfy the following binomial heap properties. Right. So these binomial heap properties are like that. Each binomial tree obeys the min heap property. The key of node is greater than or equal to the key of its parent. And we say that such tree is min heap ordered. And for any non-negative integer k, there is at most one binomial tree whose root has a degree k. Right? This is the obvious point. So main point is it is min heap ordered and it should have a degree k. Now let me take an example of life. Oops, yeah, it's here. So this is a binomial heap. N is equal to 13. 13 number of nodes, and it consists of B0, B2, and B3. B3 has 2 to the power 3, 8. It has 2 to the power 2, 4. B0 would have 2 to the power 0, 1. Total number of nodes 8 plus 4 plus 1. It should be 13. Right. Now at each node, what are the values stored? So at every node there is a key value, parent pointer, degree value, and a child pointer. And there is also one more pointer, that is a sibling pointer. And for this node 12, parent pointer is pointing towards this node, and sibling pointing to this node, child pointing to this node. Right. Key value is 12 this node, degree this node, child is this node. Right. Now, to clear all, suppose I would like to take one another example to show you all the values. Let me take 8. Okay, 8 is point of reference. So there is a parent pointer There's a child pointer, there's a child pointer, there's a sibling pointer, key value, and degree. Degree, why degree 2? Because it has two children. So degree 2. Right. Now, okay. The first operation that I'm going to discuss on the binomial heap to find the minimum key value. See, right. So in order to find a minimum key value in a binomial heap, I am passing an heap as an argument in a binomial heap, and in binomial heap minimum argument is heap, and I've taken a y nil and x is that is head. Head is uh, as it is in a linked list. It is a pointer head. That is the starting point of linked list. That in the same way I am using uh, head of h to reference a binomial heap. Right. In order to find a minimum, I will initiate a variable minimum, and that I will initialize to worst possible value. The worst possible value is infinite. I don't know worst value than this, right? And in while loop, what I'm doing in while loop, I am seeing the value x. If x is pointing nil, until it is pointing to nil, I will do some operation. And what operations I am doing? I'm comparing if p of x is less than minimum, then I'm assigning minimum value as p of x, and whatever x is pointing, now y will point to this loop. And if is done, what is true? Okay. Otherwise, x will move to the sibling of x. Finally, when I'm able to come out of this loop, then I will return y. So I think you will not able to understand a single word of it. Let me show you an example. What I'm trying to do. Okay. Take this example. Right. So color of my choice would be now. Let me take orange. My favorite color. So this is head of h. X will point to this. Y to nil, right? Y to nil. Okay. So and minimum to infinite. And initialize a variable min to infinite. Then, okay. X not equal to nil. X is pointing to 10. X is not nil. So I will move to the while. In while loop, I am checking if key of x, that is 10, is less than infinite. Yes, 10 is always less than infinite. So now value of minimum will be 10. Value of minimum will be 10. Done. Now the value of minimum will be 10. Now what I will do again, whatever x is pointing, now y will also point to that thing. Done. And next x will be sibling of x. Sibling of 10 will be this. Now x will be here. Okay. X is pointing to some node not equal to nil. So what I will do, I will move into the if block, and key value of x, that is 1, is less than minimum. So now new minimum will be 1. And whatever x is pointing, y will also point to the that same concept of binary search tree. Right. Now what I will do, now new x will be sibling of x. Okay. Now new x is sibling of x if key of x, that is 6, is less than minimum. No, it is not less than. So we need not to execute if block. Right away I come out of if block, and if block sibling of x is nil. Now x is pointing towards nil. Right. So x is pointing towards nil and y is pointing towards this node. Right. So when x is pointing towards nil, I came out of while loop, and when I came out of while loop, then I return y. Whenever I return y is pointing to this one. So 1 is the minimum value, right? And I'm able to return a minimum value 1 by executing that algorithm, right? Now, somebody can ask me a question. He or she can ask me a question that why I am traversing this root list only? Why not I am examining the children. We need not to examine the children because this is the first question for you. For as I always ask question in the class for numbers, this is the first question. Why I'm not examining the children? Anybody? Plus one. Why I'm not examining the children? First three candidates I need to. One, only 10 seconds. One, two, three, four. So none answer. So all got zero. First question all got zero. Okay. Second I will see. We are not examining the children because we are taking as min heap, and min heap is always minimum value as the root, so we need to examine the only root list. That's why I'm not examining the children. Right. Okay. That's it. Okay. Now, now there is another algorithm, binomial link y and z. Suppose this is a tree whose node is root is z. This is another tree whose node is y. Now, I want to link these two nodes. They are of same degree. So what I have to do, I will make parent of y as z, parent of y as z, child of z as sibling of y, sibling of y is child of z. This is child of z. Now, child of z as y, child of z as y. And when I am able to perform these operations, degree of z will be increased by 1. Because suppose this is bk minus 1, this is also bk minus 1. So new 3 will be bk. New 3 will be bk and its degree will be k minus 1 plus 1, and this 1 plus 1 will be cancelled. So it comes out to be k. Right? Now, there is a very interesting algorithm. There are two. First, I'm trying to explain in the figure. Suppose there are two heaps. One is pointed by h1 and another is pointed by h2. I need to merge these two heaps. There's some requirement that I need to merge these two heaps to create a new heap. Right. So in order to merge these two heaps, what I will do, first let me explain all the algorithms. I'll take an example. So in order to merge binomial heap union, h1 and h2, there are two heaps that are passed, and I'm creating a new heap, make binomial heap, that is pointer is h. Now free the objects h1 and h2, and if head of h is nil, then return h. Now I'm taking the three pointers x, suppose this is x, this is head of h, three pointers, this pointer, suppose g is there, this is x, and previous of x will be nil, previous of x will be pointer towards a previous node, and next of x is sibling of x. So next of x is sibling of x. Sibling of x. Right. Now what I'm doing, while I'm traversing the root list, and whenever I'm not able to get a nil, I will keep on doing moving. And in this, I'm checking a condition. This if condition, I'm checking a condition. This is your question number 2. What this if condition explains. Degree of x not equal to degree of next of x, or sibling of next of x is not equal to nil, and degree of sibling of next of x is equal to degree of x. You just need to tell me what this if condition is telling. You must have studied if condition in first year, so must be very, very comfortable. The second question is what this if condition is telling. Now, what I'm doing, if this condition is satisfied, if this condition is satisfied, I'm assigning x to previous of x and next of x to x. If not, else I'm checking if key of x is less than key of next of x. I am assigning sibling of next of x to sibling of x, and then I'm compiling a binomial link. Next of x, x means these two are of same degree, and I'm y, z. Now I will make z as root and y is left child. Else what I'm doing, else again I'm checking if previous of x is nil, then simply head of h is next of x. If not, then sibling of previous of x is next of x, and then again I am binomial linking x and next of x. What this function do, next of x will make root and x is next, and finally move the x pointer to the next of x. Finally, when I am able to come out of these loops, sibling of x is next of x. Finally, I am able to make union of 2 and return of h. So anybody able to decode this question? If so, it means none is listening. Great. Question number 2, 0. So you're left with only 3 marks. All want 0. Your choice. Can't help it. So for attendance, I've shared a form along with a quiz. So you have to attempt quiz, but you will be marked in 3 marks. Total value is 4, but whosoever will be scoring 4, it will be considered as 3. Whosoever score 2, it will be considered as 1. Still, anybody want to take an attempt? What is this if condition is telling? Question is what this if condition is telling. First question, nobody responded. Second question, what this if condition is telling. Just make an attempt.
इसमें क्लियर करा गया है कि जो है अगर उसके सिबलिंग की डिग्री के इक्वल नहीं है या फिर सिबलिंग जो है सिबलिंग का वो निल नहीं है और एंड डिग्री ऑफ सिबलिंग ऑफ एक्स, मतलब नेक्स्ट जो हम लोग का सिबलिंग को पॉइंट कर रहा है और डिग्री उसके चाइल्ड्स को पॉइंट कर रही है. एक्सप्लेन कराइए थोड़ा सा, मतलब कंडीशन ऐसे पता नहीं कि क्या होता है.
नहीं ये अटेम्प्ट वेरी गुड बट नॉट करेक्ट. ठीक है, कोई बात नहीं, हमें करेक्ट और अनकरेक्ट से मतलब ही नहीं था, मुझे तो सिर्फ अटेम्प्ट से मतलब था. ओके, लेट मी शो इन अ फिगर. So suppose this is situation. When I merge these two, so head of h is now pointing to this. X is this, next of x this, and previous of x to nil. Right. So this was our algorithm. In next case, I found two nodes of same degree, x and next of x. So when I found two nodes of same degree, it is a min heap. So minimum value key is at the root. So 12 will be root and 18 will be the child. So x and next of x will be combined. 12 and 18 will come. Right. Right. Now, x, this is x, this is next of x. These two x, next of x, and this is sibling of next of x. Right. X, next of x, and sibling of next of x. Now, you people are able to see, visualize what is this figure. Now, three nodes of same degree. Now, what I have to decide, what I have to do, whether I'm combined 12 and 7 or 3 and 7, what I'm going to do. So this is defined in the algorithm. What I'm asking, this is defined in this condition. When degree of x not equal to degree of next of x. See, in this condition, when degree of x is not equal to degree of sibling of next of x, right? Not equal, right? And or this is or sibling of next of x not equal to nil. Sibling of next of x is not equal to nil. Sibling of next of x is not equal to nil. It is pointing to this one. So not null. Done? No. There is one more thing. And degree of sibling of next of x is equal to degree of x. See now here comes the concept. Degree of sibling of next of x equal to degree of x. See what does it mean? That this is degree of x, this is sibling of next of x, both degrees are same. It means this is depicting this situation, and in this situation three nodes, three trees are of same degree. So now we can able to decode what this is telling. This is telling when there is a same three trees of same degrees, then we will perform cases 1 and cases 2. Right. Those who have attempted may be able to got what is the concept. Those who not tried. So happy listening, happy attending tute for attendance. So in this way, I'm able to combine 3 and 7. So 3 is a minimum compared to 7. So 3 and 7 will be combined. Now x is this, previous of x is this, next of x is this. Now 2 of same degree, 3 and 15. So 15 will become leftmost child of 3. Done. Now all the in this binomial heap, all the trees of different degrees. Because why am I able to combine? I'm able to combine because whenever there's two trees of same degree, I will not remain them same. Two b1 are there, I will make it b2. Two b2 are there, I will make them b3. So this is the concept of union, and this is the algorithm, right? So I've shared attendance form for all of you, and along with two questions. So Abhishek, what was your roll number? I think 4. What I remember from yesterday, previous classes.
Yes, sir.
Okay. Abhishek got attempt, so I'm assigned 1. Rest will be evaluated from 3. So just attempt those questions and fill the attendance form. It will be shared as Tute 52, right, with the name of Tute 52. Just tell me whether you people are able to see it. If not, then I will create another form. Just check it and tell me fast. And it will be open only for 5 to 6 minutes. So just attempt fast, very fast. Please, somebody tell me that your people are able to see it. Heading is attendance and SQ7. Right. I will not let you let this form open for more than 5 minutes. So please attempt fast. Okay, great. Rishabh, thank you. So this much I'm going to cover in this class. Those who have submitted can leave. And I would like to revise this union algorithm. This is the toughest algorithm in this binomial heap concept. Rest is very easy.